Welcome to Rges Pre-Algebra. This is Lesson 6B, and we'll be working with lessons in the book 129 through 131. So 129 has to do with solving ratio problems. Now recall that a ratio is just a fraction. It's a relationship between two numbers, like there are 2 boys for every 5 girls on the team, something like that. We could certainly write it like this, 2 to 5 this way, or 2 to 5 as a fraction, which is actually the most common way we see it. Now, a proportion is 2 ratios set equal to one another. So if there are 2 boys for every 5 girls, how many boys are there for every 25 girls? Something like that. So we would have the boys represented on the top in both ratios, the girls represented on the bottom, and a proportion, recalls, is where you have 2 ratios, ratio 1 here on the left and ratio 2 here on the right, set equal to one another. So now you can solve it. And the way we solve that, one of the ways we talk about solving that is we say something like cross multiply. And to cross multiply, it simply means you take the top left and multiply it by the bottom right, like that. And 2 times 25 is 50. Okay. And you take the bottom left and multiply it by the top right. So 5 times x is 5x. And then you would divide both sides by 5. So x equals, or you say 5 times what equals 50, and x equals 10. So there are 10 boys for every 25 girls. That would be the same proportion. Now, there's plenty of different ways we can look at this. A proportion's a powerful idea and makes for good. Okay, so what we're saying is in the same proportion as 2 is to 5, that same proportion would be 10 for every 25 girls, 10 boys for every 25 girls. Now, there's other ways we could also consider it. If I go back to my proportion, I say 2 is to 5 as x is to 25, I can ask myself the question, what do I have to multiply 5 by to get 25? And the answer is 5, and so therefore also multiply the numerator by 5, and 5 times 2, x would have to be equal to 10. Okay, so that's another way we can solve a proportion. Let's look at a couple of these examples. So the first example says on a map, 5 centimeters represents 200 kilometers in real life. So centimeters on the map and kilometers in life. That's okay. 5 represents 200. So how many centimeters would I need to represent 500 kilometers? Notice if it's kilometers that I'm talking about that are 500, I would have to make sure that lines up with kilometers over here, so that would be in the numerator. So that's probably one of your biggest tricks, is just making sure you're comparing the same thing on both sides. So we don't know how many we would need. Notice it would be about, it would be 2.5 times, right? But I don't have to do it that way. I could do it the cross multiply way. I could easily start on the bottom on the left to the top on the right, it doesn't matter, rather than the top on the left, and that way I would get my 200x on the left side of the equation. 5 times 500 is 2500, and then you would divide both sides by 200 to get the x all by itself. I want this to go to the other side, so I'm multiplying now. I want to divide both sides of the equation, and that would leave me with 2500 over 200. I'd cross through my 2 zeros like that, and 25 divided by 2 is 12.5. And so I would need 12.5 centimeters to represent 500 kilometers. Let's look at another one. The next example is a little bit tricky, and I'm going to show you why. And it just illustrates the necessity of labeling. Okay, it says the Greer volleyball team played 25 games. The ratio of games won to lost was 3-2. So won to lost, that ratio was 3-2. And if I have, but I'm not given games lost or games won, what am I given? I want to know how many is won, so 1 is my question mark, and I'm giving the games played. So now I have to make a ratio with the games won to the games played. Does that make sense? Because I'm given the games played, and which is 25, and I want to know how many are won. So it's these two things, won and played, that I need to express in my ratio. So I'll put the number 1. I've already given that. Okay, but how many would it be played in this ratio here? Well, if it's 3-2 altogether, we have 5 games played. So that's kind of the trick to the problem. And then I know that in reality they played 25 games, and I want to know how many they won. Okay, so this right here is the trick. Okay, they gave me 3-2, but I need to convert that to 3-5 because 5 is the number of games played in all up here. Okay, so again, I can do it two ways. I can cross multiply, or I can ask, what do you multiply by 5 to get 25? And the answer is 5. So if I multiply the denominator by 5, I need to multiply the numerator by 5. And so x equals 5 times 3, or 15. They won 15 games out of 25, or a 3-2 ratio. So you go ahead and work through those problems 1 through 10 and see if you can't make sense out of them on your own, and come and ask me any questions when we're together. Okay, looking on the top of page 45, it has a problem-solving strategy, and it gives you an example. Abigail bought a 14-ounce box of math bits to make some cereal treats. The cereal cost $4.27. What's the unit price to the nearest tenth of 1 cent? Okay, unit price is the cost for 1 unit. So if we have such as 1 ounce or 1 pound, so you would set up the proportion as your cost. We want to say cost per ounce. Okay, so the ounce, because it tells me it's a 14-ounce box. So if it's anything per something else, we do want the cost in the numerator and the ounces in the denominator. At least that would be the most logical way to set that up. Now, what is the what are we given? Well, we're given 14 ounces costs $4.27, and I want to know how much is the price. So that's the price up above. What is the price for each 1 ounce? Cost per ounce. Okay. And again, you could cross multiply. 14x equals 4.27 times 1, or 4.27. Then you would divide. Okay. And you could either decide to do some canceling, or you could take it as a long division problem. Either way, it should come out correct. I could do it that way. Or I notice that, 42 is 7 times something, and 7, right, comes in even to 7, goes in even to 7, goes in even to 7. So if I cancel, I would get 0.61, taking 7 out of the bottom, out of 2, and then I can do my division quickly. Half of 61 is 30.5. So it would be 30.5 cents, or 0.305, 30.5 cents per ounce. Okay. So go ahead and just do those ones in the blue box on top mentally, and then let's go on to the next concept. The next idea is percent. This is the percent symbol, and percent means part of 100. So if I say 25%, that means take 25 parts out of every 100. If I say 3%, that means take 3 parts out of every 100. So it's very easy to convert from percent to fraction. All you do is put the number over 100. Now, how would I convert percent to a decimal? Okay, well, just as we learned already actually how to convert fraction to decimal, we would move the decimal over 2 places. So if I can take 25% and I want to move that to a decimal, that would be moving it over 2 places. So 25% is the same as 0.25. 3%, 3% is the same as 0.03. Always moving it over 2 places. You might need to add zeros as you do there. If I have, let's see, what's another good example? A ratio is the same as a fraction, right? So if I have a 25%, like that, to convert it to a ratio, I would put 25 over 100, and then I would reduce it to lowest terms, 1/4. Thinking about this from another angle, let's say I want to go from decimal to percent. If I have 0.09, that's my decimal, and I want to convert that to percent, that would be 9%. Right? Okay. They're going to ask you to do some rounding, and that's just for review. If you have a fraction as a percent, let's talk about how we would do that. Well, I'll give you a couple examples, and then you can think about it and see if you can figure the rest out for yourself. Let's say I want to get 4/5, and I want to convert that to a percent. Okay. Now remember, percent is over 100. There's lots of ways I can do this. One, if I memorize this, which you should have, that is the same as 0.8. And since I want to go over 100, that equals 0.80 or 80%. See how that works? Now another way I could do that is I could say 4 divided by 5. Right? And that would be 5 goes into 48, and then I want to go over 2 decimals, so I can convert that to the percent. Let's see, another way I could do this, because percent means over 100, I could do it as a ratio, or a proportion. 5 times what equals 100? 20. So 4 times 20 is 80. And 80 over 100 would be 80%. So you have several tools at your disposal now. Sometimes they just depend on how easy the numbers are, especially in the denominator. So go ahead and do the rest of 1.30 on your own, and let's look finally at 1.31. Okay, now we're talking about the concept of 17, let's say 17% of 352. Well, 17% is the same as multiplying by, so we're going to multiply, so when you see of, think multiplication. So this would be 0.17 times 352, and you already know how to do that. Another way I could look at it is 17 over 100 equals what over 352? And so because 17 Well, I'm sorry, this is a 17, because 17% can be written as 17 over 100. So I could solve this by cross-multiplying as a proportion. So those are the two ways they're recommending that you do these. Go ahead and do the rest of those problems. I would say if the numbers easily go in to convert with a simple proportion, it's well worth your while to do it this way. If they're sloppy, which in this particular case they're not very easy to see how it multiplies, then I would go ahead and just convert it into a decimal. Okay, bring questions to class.